negative 4 there. So good thing is, right, we got 1 right off the bat. We didn't have to work for it. However, we will have to work for the other 2 itself. Okay? So now we have to add up, plug in negative 4 into the other system. So we're going to have 5 is equal to negative 4 plus b plus c. And we know negative 3 is equal to negative 5 plus times negative 4 gives you positive 20 minus 4b minus c. And now this goes back to system of equations, right? Way back in the day, how to solve for system. So bring this over. So we have adding gives you 9. And then subtracting gives you negative 17. Okay. And now we solve for a system. So if you guys remember, we can use elimination or substitution to verify which one we actually want. Okay. So probably elimination would be the best, because notice if you add straight down, c's actually cancel away, which is the best part. So 19 minus 17 gives you negative 8. Yeah. That equals 1b minus 4b gives you negative 3b. And those cancel, right? So we get this. So dividing over, we get b is equal to the fraction of 8/3. And again, now we can solve for c. Right? Just going backwards when it comes to it. So we know, if you want to use this, for instance, 9 is equal to 8/3 plus c. Okay. And then, subtracting it over, right? So this is going to be 8 and, oh no, 8, what is it? Subtract it, 9/1 minus 8/3. So 27/3. So that is 16/3. If I did my math correctly. Oh no, that's not it. 18. Oh, I don't know. 19. There we go. Sorry. 19/3. So C is equal to 19/3. Okay. So therefore, we know all three. So A was originally negative 4, and B is that there. Okay. So that is how we're going to solve for each individual variable. And guess what? We're not even done yet. That just sets up each individual integral. So these are going to be very, very long problems. Okay. So how do we put everything to play? So how do we start? Do this, then this stuff, and then finally take the integral. Because hopefully the integral is very easy, right? Because after all this work, you don't want an integral, you have to do another 20 minutes on to figure that stuff out, right? So let's see how it's go about. So let's try our first full example of using integration by parts, or not integration by partial fractions. Okay. All right, so we have this one here. Well, we have already one step down, right? Thank goodness they already factored it. So we know it's going to equal to a over x plus 4 plus b over 2x minus 1. Okay. All right, so again, we're going to have x equals, and then again, we're going to want to multiply what we need, right? So in this case, and if you add these two fractions together, we multiply top and bottom by 2x minus 2. And on the other side, we'll multiply by x plus 4. And just like last time, now we just distribute. Okay. And put everything together. So all the x's together. So that has an x, that has an x, and all the other numbers together. So minus a plus 4b. Okay, so now, according to what we have, we know all the x's, so 2a, so 1, right, that's the coefficient of x, 1 is equal to 2a plus b. Right? And we also know that 0, right, because we have no whole numbers, right, they're just technically plus 0. 0 is equal to minus a plus 4b. And now notice we can solve for a variable automatically, right? Or like, use substitute, bring this over, so we know a is equal to 4b. So this one, probably substitution would be the best instead of elimination, right? So we could just substitute this for the first one. So I'll substitute a for 4b in here. So we know 1 is equal to 2 times 4b plus b. So that gives you 8 plus 1 is 9. So dividing over, so we know b is equal to 1/9 itself. Okay. And then we just go backwards. We know this is true, so we know a must also be, if I multiply, 4/9. Right, just multiply, plug it into here. 4 times 1/9 is 4/9. So how does this come into play now? So this ends up being the integral of a, which is, I'll just put in the front 4/9 times 1 over x plus 4 dx plus the integral of 1/9 times 1 over 2x minus 1 dx. And now notice we can bring this up, and now we integrate each one individually. All right, so notice each one is a pattern of natural log, right? So we let u substitution, let u equal x plus 4, then du is equal to just 1x. So this is just the integral. Integral of 1 over u, which is natural log, right? It's the property. So I can just I'll just quickly skip that step to deal with it. So this is going to be 4 over 9 natural log of x plus 4 for this side. And then plus, following this side, it's going to be a little different because if we let u equal 2x minus 1, therefore du is actually 2x, or 2 dx, which I can't have, so this is actually 1/2 du. So this ends up being the integral of 1/2 over u. Okay. So putting these together gives you 1 over 18 natural log of exactly that, plus c. There, believe it or not, is our final answer there. So lots of work. Okay, so a little recap. First, we break it up. We want to do it technically what we would do if we actually want to put these together, fractions together, right? So multiply what we don't have. Group them together into such a way that we can have all the x's and all the variables into one part. Therefore, we know each one sets, right? Each one 0. Solve for them. Go back, and then finally integrate the old-fashioned way like we did before. Okay, so lots and lots of work for these type of problems. Okay. All right, so let's try another one down here. So again, good thing is it's already factored, so we're going to do a little bit less work right when it comes to it. So we're going to have a over 3x minus 1 plus b over x minus 1 plus c over x minus 1 squared. Just like that. Okay. All right, so if I distribute this top, we're going to have negative 5x squared plus 3x is equal to a times x minus 1 squared plus b times x minus 1 times 3x minus 1, and then plus c times 3x minus 1, right? Because that's the only thing that's missing from our denominator, or what this has, right? So horrible, horrible, horrible mess, right, when it comes to it. Right? So I'll let you guys just do that portion, just try to skip that step for time, right? So this is just, foiling. It's not too much of a big deal, right? So eventually I'll just put to you guys what we actually need. So we're going to have this is equal to ax squared minus 2ax plus a plus 3b x squared minus 4bx plus b plus 3cx minus c. Okay. All right, so again, putting them together as best we can. So we have ax squared here plus 3bx squared, and that's it for the x squareds. So minus 2ax's, we have one there, minus 4bx, and then there, plus 3cx, And then lastly, the single numbers. So a plus b minus c. Okay. All right, so if we follow this up, right, so all the x squareds added must equal -5. So we know -5 is equal to a plus 3b minus, oh, that's it. That's the other one. So there you go. So -5 is equal to a plus 3b. We know 3, if with single x's, so that's from here to here, right, is equal to -2a minus 4b plus 3c. And we also know, right, there's technically 0 x's, a 0 whole number, so 0, just like the last question, is equal to the last 3 there, a plus b minus c. Horrible, 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 huh? Kind of distressing. Okay, now we got to solve for each one individually, right? Okay, so we know, right, let's see, we have 2 terms here and 3 terms here, so the only way we get rid of it, right, we always have to do 2 terms, so I want to leave this by itself. That's probably the best way. So let's see here. So let's get rid of this c since we're already a negative. So if I multiply this by 3 and then redo this, I'm going to have 3 is equal to -2a minus 4b plus 3c. And 0 times 3 is going to be 0, so 3a plus 3b minus, 3c. Add straight down, that goes away. This is 3. And what does this give us? Positive a and minus b. All right, so that's not too bad, right? Now we can